Welcome. Today we are going to be introduced to some of the properties of logs that will later allow you to solve logs more easily. All right, right now you're just learning about the properties. We won't get to solving them. We'll have to have that in the next class. But I'm going to talk about properties of logs. So there's some really good properties of logs that are useful. First of all, look at this one right here. If you have the log of some base of that base, that equals 1. So log base 10 of 10 equals 1. Now let's prove that with writing it in an exponential. If I take this one and write it in exponential, it's base 10 raised to the first power equals 10. That's a true statement, right? So generalizing, if you have the log of some base of that number, it equals 1. Okay? You can easily show that it's true. The log of any base of 1 equals 0. And that's because when we looked at these graphs, this ended up being our x-intercept. But let's look at that one. Log base, we'll put 7. Log base 7 of 1 equals 0. To understand it, let's look at it in its exponential form. 7 raised to the 0 equals 1. Right? So any base of 1 is 0 because that base raised to the 0 equals 1. Any number raised to the 0 equals 1. Okay, so it makes sense that holds as a property. This last one we'll get to shortly. First, I want to look at the product property. So it's telling us that if I have a log, I'm going to leave the base off. If I leave the base off, what does that make this log? Makes it the common log base 10, doesn't it? But I'm just going to leave the base off because I don't want to have to keep writing b. So the log of something times something else. Two factors multiply together, get a product. You can expand, we're going to expand this log into log of m plus log of n. This is going to help us both directions, whether we expand, which is the direction I just did, or if we go backward, we will call that condense. Okay, and we'll do some samples, more samples at the end. This is going to help us when we have to solve. So for example, if I have log of 3 times x, I can expand that to say, well, it's the log of 3 plus the log of x. All right? So this is what we call the product property. Let's look at the quotient property, right? Quotient is division. So when I have, they're using a fraction here. This is m divided by n, right? This is a quotient. I have a different property. So log, we'll just leave it as common logarithm base 10 of m divided by n, log of m minus log of n. So on the first page, we found that if it's a property, you add. On this page, if it's a quotient, you subtract. Okay? We'll do more samples there. The next one we're going to look at is this power property. This is, to me, the most important property of logs. So if I have log, we'll use it like this, x to the third. Well, I'm going to say 3 to the x. Log of, right, this is log, common log, rhythm. If there's no base showing, it's base 10, isn't it? So, log base 10 of 3 to the x. If I was trying to get to that x, it's stuck in the exponent. But the beauty of this is because I take the log of this number, that x can come down in front and become x times log of 3. It's a really beautiful thing, folks. So when I'm expanding, I need to get rid of, like we want to eliminate all exponents. So if I have something like this, log of m times 2 to the x, I'm going to expand it. First thing I'm going to do is address the multiplication. Well, that's log of m plus log of 2 to the x. Okay, I'm going to eliminate all exponents. Therefore, now this can come down in front. Log of m plus x times log of 2. Right, this is, I said, by far the most important property that's going to help you solve logs. Okay? It's going to help you solve logs. All right, I'm going to back up one more. We'll show you this common base formula shortly. Change of base. Actually, it's not really bad at all. So let's say you couldn't do a base 7 on your calculator and you want to do log base 7 of 92. But we do know we can easily do log base 10, the common log, because that's on the front of the calculator, and we can do the natural log, which is base e, on the front of the calculator. So this change of base formula says I can take something that has a log base c and change it into whatever base I want. So I want to change it into natural log. So notice it'll be natural log on the top, natural log on the bottom, and the thing you were taking the log of comes up here, right? So that means natural log of 72, and the actual base from the original c comes in down here, in this case 7. So if I plug both of these into a calculator, so I'm going to do natural log of 97 divided by natural log of 7, gives me a number 2.351, right? Rounding it. Now I do know that I can get this log base 7 by using my math button and going all the way down. If I cursor all the way down, A says log base. If I click on that, I can put in any base I want. So I'm going to put log base 7 of 92. Oops, notice I had these numbers different. I'll change this to 97. So log base 7 shootsies. Try again. Log base 7 of 97, and voila, it's exactly the same number for every single digit shown in the calculator. So this change of base property is handy if the only thing you had were the common log and the natural log on your calculator. You could solve any base. Now again, we can solve any base on our calculator, but we need to be aware and be able to use this change of base formula. Okay, so I'm going to stop this here and start the next one going through the problems. Okay.